Hey everyone, welcome to the Lead in Space podcast. This is Alessio, partner and CTO at Decibel Partners, and I'm joined by my co-host Wix, founder of Small AI.
Hey, and today we are doing another quick episode on breaking news. We have a new SWE-Bench king, and part of his appeal is also that he has a great name. It's Shawn Lewis from Weights and Biases. Welcome.
SHAWN, Shawn. It's rare to meet another SHAWN, Shawn. Thanks for having me.
Yeah. Weights and Biases, very, very good friends. We've collaborated on a bunch of things over time. And so imagine my surprise when apparently during your paternity leave or just before, you release this top coding agent on SWE-Bench Verified.
Yeah, it's also somewhat to my surprise. I've been working on this for a few months and knowing that I sort of had this deadline of having a new child join the world. So it really was down to the wire. Like, you don't exactly know when a baby's going to be born. And when you're doing work like this, it's very experimental, right? It's not like I had that 64.6% result even like a few days before I published it. So my son was born, I think 2 days after we published that result.
Oh, amazing. Okay, awesome. Hell of a way to go on to paternity leave. Congrats on your son. That is always a better achievement, reproducing humans than with AI. But we're here to talk about AI. I guess my general view is that I did not expect this coming out of Weights and Biases. Like Weights and Biases is very well known. MLOps tooling, and recently you have Weave, and you're doing a lot in the sort of LLM evals and ops space. And then suddenly, like, what got you to start working on something like this?
Yeah. First of all, I think that the best way to build great tools is to be a user of them yourself. Our original experiment tracking tools that, is still what we're known for the most today. To some extent, we were able to have success there because both Lucas and I had done lots of machine learning training ourselves. So Lucas and Chris are my other two co-founders. Years and years ago, I got really interested in this problem of gaze tracking, which is, from a webcam, where is the user looking on the screen? And this was like before deep learning. I basically just wanted to have I was working at Google and people would come up and shoulder tap me as I was like doing work and I would look away. And I just wanted my screen to tell me where was I last reading in the document. And still today, computers don't do this. So I think like somebody could like make an app that does that and it would be useful because you would be able to start reading where you left off faster. So I worked on that for a long time. It was very hard prior to deep learning, but I'm like naturally a tool building kind of person. So like in the course of doing that, it was like I had spreadsheets and like, you're like iterating on code that does all these different algorithms, and then you're losing track of your like prior code that actually had some success. And so basically I was building sort of experiment tracking tools as I did that. And then eventually when we started Weights and Biases, those concepts were like first and foremost in my mind. So I hadn't had a chance to really deeply do that with like newer, like just purely by using LLMs. Of course, I use LLMs all the time, both for programming and, like everything like everybody does now. But I hadn't really had a chance to try to really build something. And I want a challenge. I want something that that I might be uniquely suited to do. And, I'm a programmer, so trying to automate programming is a good place to start. So just really like a fascinating problem and like a good hard challenge. So partially it's like, let's dog food something. Let's really try to build applications using AI in our own tools. At the same time, as AI improves, so we sell tools first of all, for people who are training AI models. So experiment tracking, right? As AI improves, like fewer people probably need to train models from scratch. It gets concentrated more and more in different, like in the big labs. And so that's a really great business for us. And like, they continue to like expand their usage of our tools. And there's a lot more that we could build there. But our mission is to like make the best tools for AI generally. Now you can get so much value from AI just by calling APIs. So we switched into like building Weave, and I've done a lot of work on that myself also, especially in the beginning of it. And then, eventually it's like AI keeps improving. So where is it like at some point, how much do people need to customize like AI using APIs? Probably, I hope a lot in the future. I hope that we don't I hope that we're not like totally automated out of jobs in the next 5 years or 10 years, but who knows? But, there's this level beyond that, which is applications. And so the other kind of the other reason to do this for us is, should we dabble in that world of applications? And, the most fascinating one and interesting one to me is AI programming. So there's like potential that we might, sell products in that space, but that's unknown so far.
Right. So we did an episode with Anthropic about their SWE agent work and like the SWE-Bench verified results that they had. One of the big focuses they had was tooling. So you mentioned tooling, obviously. I saw in your X thread about the agent that you obviously use Weave and some of the stuff you already had. And then, for example, you built a Eval studio that like you didn't have before. You built a TypeScript agent framework called FaceShift. Like, yeah, maybe talk a bit
pull
about
it up on screen? Yeah, we should show not tell.
Yeah, sure.
I think Shawn has it, so we might as well just give Shawn the screen because otherwise we'll be switching back and forth.
Let's see here.
But yeah, I mean, generally, he sort of pulls it up a by time, which is total dog fooding, right? At the same time, like you guys are very good at experiment tracking and also like running evals has always been a part of the workflow of training models. So this is nothing new in a way, but it is new in the sense that it is a coding agent, which is not something typically that we've really had to do end-to-end evals for.
Totally. Yeah. I mean, building anything with AI is a very experimental process, just like training models. So like, the way that I was able to do this basically is run a ton of experiments. And lots of people actually use weights and biases prior to the advent of, more like LLM application tools like Weave and others for evals. And a lot of our customers today still continue to use the weights and biases workspace for tracking just evals and not the process of training. The workspace, the WMB workspace, is a really powerful tool for digging around and analyzing the results of evaluations. So yeah, I mean, do you want me to like walk through some of the stuff that I made here? Sure.
Can we do the headline first? Like, what should people know? Because there's the top level thing, and then the headline results. Because I feel like we might be a bit too in the weeds already.
Sure. Let's see. Headline results.
Yeah. Because you mentioned in process. Yeah. Go ahead.
Do you mean the headline results like what did I make here, like, and why, basically?
Yeah.
Sure. Let's see. So in the course of trying to basically like build an AI programmer, first of all, at first I just built this AI programmer. I've been working on that problem separately for a long time, and there's lots of cool stuff along that path. But, to really know if something's working, you have to evaluate it at scale. These are like stochastic processes, right? So if you make it work on your own code base for a little while, like it might be good at doing some narrow slice of problems, but evaluating on like lots of problems in parallel is how you kind of like make sure that you're building something general. So SWE-Bench is, the best eval that we have for AI programming today, and the most publicly known one. And so I basically decided to work on that, and I spent lots of time on it. The work that I've done over the last few months is really all around like just improving results on SWE-Bench, almost like myopically focused on that problem. But in the course of doing that, I built a lot of, other tools to support that effort. So let's see. I'm trying to think of how to tell this story here. Yeah, I guess this process of running evals, I guess, I'm not sure I'm pretty sure a lot of your listeners will be familiar with this, but it's this very experimental, like scientific process, right? So I try like a bunch of prompts to like take a step in an agent, and I generate a bunch of results and data, and then I need to kind of like dig into that data and decide, did it work? What should I do next, right? That's the loop of research. And so the more that you can like see into the data as you work, the more visibility you have into the actual things that the agents are doing, like at a fine-grained level, the better decisions you can make along the way. So, I didn't really have that visibility in the beginning of doing this. I was using our tools Weave, which are really good at like tracing and actually running evals for you. But the views that we have in there aren't really quite as tailored to like agent workflows. And it's missing some stuff. So I'll show this sort of like front end. This is what I was calling Eval Studio. And this lets me do a few different things. So basically, what we're looking at here is the different colors, the different colored lines are 3 different evals that I ran on a subset of SWE-Bench verified here. So I've like loaded up 3 evals in this. And this kind of looks like the WMB workspace. You can do a lot of the things that you can in the workspace. So I'm like filtering down to the resolve chart here. Each point on the chart is like a agent result on a single instance within SWE-Bench, an instance being like a GitHub bug in a GitHub repo that the agent tried to solve. So each point is the agent result on that instance and the scores for the instance. And so this chart here is like the final score that we're looking for on SWE-Bench, whether or not like the problem was solved. And so before I didn't pull up the spreadsheets. Everybody's gone through any of this work without tools. Like spreadsheets are such a great tool.
Spreadsheets
right?
are all you need.
Spreadsheets. And so I've done lots of work in spreadsheets despite being the CTO of Weights and Biases. Let's see here. This is
what is this?
So this is the tool that I was using prior to having this kind of workspace tool to plot as these evals were running. How are they doing against prior evals? So a SWE-Bench eval for me takes about an hour to 2 hours to run on like a subset of 100 problems. And, you kind of want to know as it's going, like what's happening, and partially like to decide whether or not you should actually continue running that run. Also just because you're excited to see what the result will be. So this spreadsheet is what I had some other tools where I would have like columns of data for each eval, and then I would have to go to the other tool and copy a column out and paste it in here. And make like these little plots. Eventually that got replaced by this workspace where I can just load up data. I should say all the data in this is backed by Weave. So that's our tools for like applying AI. Everything from my FaceShift framework, which is a new TypeScript framework for building agents, is logged to Weave automatically. So there's basically no backend for this new Eval Studio tool that I have here. It's all backed by Weave data. So let's see. So yeah, this view is really useful for looking at charts as things run and then comparing runs at kind of a high level to understand what happens. So another really useful view to look at is if you plot reasoning tokens on the x-axis and then like a cumulative sum of what instances were resolved over time, you can sort of see different shapes in these charts. So this blue line here kind of has a kink in it. If you look at how it looks like it's going up really steeply and then it shoots out to the right. These problems to the right of that kink are problems that use significantly more reasoning problems than all the ones running up that reasoning tokens than all the ones running up that slope. There's a question here. I can't like answer this without digging into the data, but it's like, why were there some problems that seem to be like very easy in terms of the amount of reasoning, the amount of thinking that you have to apply to solve them versus others that took much more reasoning? So it's really useful to be able to just sort of dream up something to plot and be able to actually plot it and see it in a UI like this. Good.
Do we want to run through also the models that you built on? Because I think the headline is kind of O1 driven, but then I know you use a bunch of sub things, and maybe also talk about how you kind of wrangle them together into this and talk about FaceShift and that.
Yeah. Maybe that's the headline that you're looking for. So yeah, so I guess I think for me, like using the latest and greatest is like one of the major reasons. The other major reasons to do this, reasoning models. So the agent that I made here is purely based on OpenAI's O1 model. And I think it was the first, published result on SWE-Bench that, and maybe the only one, still as of a week later, that uses O1 to both drive the agent logic, so the step-by-step logic of what should we do next, and like all the programming that happens. I think, it's also just incredibly valuable to us at Weights and Biases to understand how the new models work, right? And applying O1 is very different than using GPT-4. It does different things. Like it's very good at doing exactly what you say, and sometimes almost like doing malicious compliance, where you like had something in your prompt that told it to do something, and it really complies to what you said, despite there being like maybe a better alternative. Where it feels like to me something like GPT-4 will sort of ignore stuff and just like keep plodding down the same path. So this agent is purely based on O1. And, there was a lot of like experimentation and learning to do to like make O1 work in this way. I think OpenAI, they published their SWE-Bench verified O1 result when they released O1. And I think they solved something like 49% of problems. So this solves 64% of problems. It solves like something like 57% of problems with a single rollout, and then using parallel rollouts and selecting the best one with other techniques, we get something like 64%.
Right. So I think, did you compare this with the other agent approaches that the other folks adopted, or were you just kind of doing it first principles?
It's all done from first principles. And I really would like to, I didn't get a chance to actually run Sonnet through this all the way. So I don't know what the result would be if I just dropped Sonnet in here. Just dropping a model in is not really like ever possible. You kind of have to like tune things, like I would have to do a bunch of experimentation to give it a fair try. I actually just didn't have like a high enough rate limit on Sonnet at the time I was doing this. And that's why I like didn't end up running it a lot.
Yeah.
Yeah, go ahead.
Well, the sort of apparent meta game from Paul Gauthier on Aider is that you use R1 as an architect and Sonnet as a code model, and that's apparently the best combination that beats O1 for him.
Yeah, I'm surprised about that actually, because I think that it's actually, O1 is very good at programming, but it's kind of the agent part was the harder part to get it to do here. I think it's like less trained to take the next step in like an agentic task, whereas GPT-4 for like the last 2 years has been really, pretty decent at like taking a long sequence of steps to solve a problem and being able to refer back to like prior steps in the right order and stuff like that. Whereas it feels like it kind of gets confused. So yeah, I'm surprised. Like I would actually flip that around if I was going to try that, to start. But, it's like, again, you have to experiment a ton, and that's probably where he ended up.
Well, it's also a different benchmark. He's using it for sort of code editing, whereas this is much more quote unquote agentic, for whatever that word means. But yeah, it's a really good result. Any other sort of approaches that you found out meaningful? So like when you were developing, you had this little proto framework inside of Google Sheets. What's one thing you noticed that sort of changed your mind as to like your agent development? Basically, I'm looking for an example where basically kind of looking at your data as it evolved actually affected the way you develop the agent.
Sure. Yeah, I mean, I can give you kind of like the moment that really maybe accelerated my progress when I got these tools working well. Oops, so let's go back to this tab. So this is like a simple table where along the rows we have each of the SWE-Bench problems in the data set that we're looking at, and we can load up other columns from the 3 evals that we've selected on the side. So what I typically do, and there's all kinds of ways to use this, but what I typically do is I just load the final score values for each of the 3 evals next to each other, and then sort these columns like this so that I can say, for example, let me see cases where this new eval, let's say I just ran the one on the far right, failed on problems, but where the prior evals that I've done succeeded. And sometimes I'll load like 10 other evals here, and you'll have like everybody was getting it right. And then, our new one got it wrong. So this is an interesting problem to look into because it may be something that was very easy until we changed something in the prompt or in the framework, and now it's broken. The other important thing to note here before I dive into the traces is this column was also very useful to me. Everybody who's ever working on this should do what I did here. So basically, I took all the public SWE-Bench leaderboard data, and I just counted how many times every instance was solved by somebody on the public leaderboard. So that basically gives you a difficulty score for every instance. So if we go down to the bottom, you can see all these zeros here are SWE-Bench problems that have never been publicly solved on the leaderboard. And there's actually quite a lot of those problems remaining. So if we look at this problem here, this is one where basically everybody on the leaderboard solved it. My 2 prior evals solved it, and yet this eval didn't solve it. So what's going on there? And once I had the tool really able to load these up and look at that view of just at the example level, what things am I doing poorly on that other prior runs had done well on, I started making a ton more progress. So from there, I can really easily dig into the agent trace. And I've picked a run. I might need to load another one for you. Well, let's just look at the other one as an example.
And so the idea is that you run all these through Weave, and Weave stored it all for you, so it's easy to pull up, right?
Yep. All this
It's the
data
same
is like
backend.
permanently kind of stored in Weave here in WMB. So
it's kind of like a different view of Weave that you've built.
Exactly.
Like a different front end. Yeah. Okay.
Yeah. So here in Weave, we see like these are the raw eval logs that I've done. You can see in the course of this, I did something like 1,000 evals. And there's all this data in here. And Weave has lots of tools for digging into traces and like looking at a fine grained level at this stuff. But this tool gives me an easier way to pivot the data and then dig in to get a more agentic, call it, view of what's happening. So maybe we can define that a little bit as we like look at this. What this shows me is the linear sequence of steps that my agent took to solve one of these SWE-Bench problems. And so at each step, I can see what the LLM, the complete LLM output was, what the tool calls were that were made in that step, and then what the state of the current observation is here on the right. And for me, the way that this agent works is it has an editor that it can see like code that it's opened here in this observation. And so as we scroll through here, you can see like here, the agent decided to expand a function in the editor. So in this editor, everything starts off collapsed. We could turn on line numbers to see that. So the agent actually sees every line in this Python file prefixed with line numbers that look like this. And when there is a range, it indicates that that function was collapsed, kind of like, code collapsing that you would have in VS Code. So the agent, expanded this function so that it could see what was in there. Let's turn that back off. And as we go to the right, we can just sort of flip through this trace and see what it's doing. So here it's writing a test script, running the test script, making an edit in the code base, and so on. And so the sort of process that, now I can like really easily follow using this tool is to do a new run, look for things that went wrong, especially things that everybody got right and now we're getting wrong, and then dig into this trace. And really, you cannot avoid this last part. Like I've tried a lot to automate parts of this by, I've tried a lot to automate it to remove the need for me to actually like manually inspect all of these traces. And I'm here to tell you like today, that is still impossible. You basically always have to look really closely at data for anything that you're building.
And Shawn, what would be your next step from here, right? So you're building this agent, you can see the traces, you see there's some sort of behavior that regressed. How do you go back and figure out, is it a prompt change issue? Is it a tool description change issue? Like, how do you debug it?
Yeah, I think, so let's see. My process is there's still other like nice like new tools involved in this process, right? So it's really like I'll flip through these traces and kind of like for each one I'll write down notes about like what I thought went wrong there, and I'll do that for like say 20 or so, and then I kind of go, okay, what's the biggest problem that we encountered in these like 20 failures? Let's go try to fix that problem. So in the case where we just ran a new run and we're doing that, we know what we changed from the prior run to this run, right? So there's like a lot of signal in like we edited the prompt and now we have these new failures. And so that can indicate a problem. I think one interesting thing about Weave that maybe other tools don't do is it's really good at tracking both your code and your kind of configuration all together. So the FaceShift framework makes the best use of Weave possible. Weave is fairly low level and it's a little bit, tricky to set up this kind of tracking. So FaceShift makes this really easy on top of Weave. But what we're looking at here is diffing like two of those evaluation runs, the configurations for those two evaluation runs. And if we drill into, so the question that I might have is like, what did I change from the prior run that worked on a problem and this new run that's failing? And we can drill into like the exact configuration of the FaceShift code here to see what changed. So everything with a yellow highlight here on the left is something that changed. If we go into this environment, I can see that I like configured the environment, which has all my tool call code a little bit differently here. So, there's a couple configuration tweaks. But then also in this prompt, down inside of the format function. So now here we're looking at a function, not like a fixed string, because these probs are complex and have, all this concatenation and stuff going on. We can see exactly what changes I made, what the delta was from one to the next. So, the process is like, we know that we made this change here where we said take the best step instead of the next assistant step to complete the task. And like, how does the LLM think about that and interpret it differently? And why would it result in these like different outcomes?
And what's the plan with FaceShift? Because I think in the blog you mentioned you wanted to polish it up and then release it. Do you have a timeline or any other stuff outstanding that you really want to build before you release it?
Yeah, I would love to get it out there. I think, I built this in the course of like really trying to solve that SWE-Bench or do really well on SWE-Bench first and foremost. So it's kind of like tuned to Shawn today. So it needs some like good like cleanup and, all the stuff you would do to really open source something and make it great. But I do find it, incredibly useful myself. And it was able to get this great result. So I'd love to share it with the world. I think, it lets me kind of compose together any ideas I have really quickly now and test them out. So yeah, I guess I can't give an exact timeline yet, but it seems like that's next on my list, especially because people have been asking me a lot about that. So it's nice to see the interest.
Can you use your agent to polish it up? Or I guess like that's another good question. It's like, there's kind of this SWE-Bench verified benchmark. And then there's like, the more programmatic, how am I going to use this agent?
Totally.
What are maybe, something that you've been using it for that are being great, or are there some use cases that don't really translate from like benchmark to real world?
Yeah, great question. Well, I'll tell you something funny. Everything in this, in the FaceShift UI, this Eval Studio UI that I showed you was written by AI. So this entire UI was written by AI, but it was not written by FaceShift. It was written by Cursor. And it's not it. Because as I was doing that, it's really the interactive development process that I want of like looking at the UI and saying, oh, add this button here, move this over there, give me some charts here and there. So FaceShift is really designed for like longer running agentic tasks where you look away for a long time and come back and you get some result. The other thing is I just haven't made FaceShift, the framework, actually be able to run on my local file system yet. It's sort of an evolution of a prior thing that I made called Programmer that I've used a lot on my local file system to like write code, to write analysis tools, all this stuff. But FaceShift itself in TypeScript basically can only run on SWE-Bench verified today. So, other folks have been suggesting on Twitter, well, maybe fix it up to like edit itself and then see if you can clean the framework up.
Cool. There are a number of other things you mentioned. You wanted to write about cross-check. It seems like you're going to have a blog post about that. And then also there's like just the general submission process for SWE-Bench verified. They're asking for your traces. I'm sure there's nothing super proprietary there, but like, yeah, just anything else that you are going to release, in the coming days.
Yeah, totally. Well, let's combine that into a single question. I think SWE-Bench is this like, it's an amazing benchmark. It is like, it's really like a bellwether of like, can agents independently solve real world programming tasks? They're kind of small problems typically, and they're like tractable and known to be in different ways. But it's a great benchmark, and the folks who made it, I think, deserve like tons and tons of credit for giving that to the world. And one of the really important and good things that they did is they require trajectories to be submitted.
We talked about this with Cosine and Anthropic as well when we had their interviews for them for the same benchmark that you're now on top of.
Yeah, I think if they had chosen to say, okay, just give us a result, we'll publish it, it would just be much less useful to everybody who was like, following along, and, harder to verify even what they're doing. So when I submitted this, I put together like all the trajectories that include the parallel rollouts and the results of the final cross-check step, which is a step that can take different trajectories and combine them to figure out like which one was correct. So I submitted the trajectories from all of that and a write-up in SWE-Bench verified submissions about how that step works. So I don't think anybody realizes that that's there, because unfortunately, the trajectories directory, when you submit, ends up getting uploaded into S3, and it's actually kind of hard to get it out. It's in a private bucket. But if you go to my fork of SWE-Bench verified where I submitted this of the experiments
Trash.
repo.
Yeah, a
You
lot
can
of people do
see
this. Yeah,
the full submission. What's that?
yeah, a lot of people do this with like the fork, and then you have the JSON files there.
Yeah, so like if you want like alpha about how to make AI agents, like go figure out the crazy process to get your AWS credentials and download all these trajectories and what people have written. I think Google has a write-up of how their submission works, like buried in this directory too. So I wrote up how cross-check works here, and you can go read this, and like figure it out. I think I can talk about this if you want to. I thought it was interesting when I made it.
Yeah, well, I mean, one thing on the cross check, I think, is something that people are interested in. I think the other agent builders, I won't name names, who are sort of, although slightly salty that you came out ahead of all of them, are kind of flagging this as like they're sort of like, you basically send like a modified rejection sampling. I think you have a different view. I think the way that you explained it is kind of like choosing between trajectories. I think that's that's an interesting algorithm that no one has articulated before. So maybe a brief take on that.
Sorry, so can you explain the saltiness? Like what's the
there? Okay, again, I won't say who this is from, but I did talk to one of the other people who is in the arena on SWE-Bench verified, and they were like, "Oh, what do you think about this weights and biases one?" And he was like, "Yeah, it's great, but like they just ran O1 5 times and then chose the best one." I'm like, I could do that too. It's just like, super expensive. But that's the dismissive.
Yeah,
take.
I think all the top submissions. So I don't know about there's one called like Black Box that was right below my submission. I don't know what they did, because it's Black Box, I guess. The one below that from Aid from Code Story Aid did the same thing. Like they run multiple trajectories, then they have a strategy for choosing the best. The Google submission down below, I think, ran thousands of trajectories and then has a strategy for choosing the best. If you want to get to the top of the leaderboard at this point, you probably need a strategy like that somewhere and be willing to like pay the cost, whatever it is. But it's also like, it's really important, like to be able to move up 6% by doing something like that. Like the problems, remember, get exponentially harder as you go up the leaderboard. So if you can solve 6% more problems on SWE-Bench, you're doing much better than you were at like 60%. So basically everybody's doing that. And there's a submission, I think, that will top the leaderboard whenever they accept it, that has done that even more extremely than mine. So
yeah, isoform. Yeah.
Yep. Yeah, exactly.
Always
I
a
think
fun
the
game.
strategy that we have here for choosing them is different than what other people have done. Like this, I think this works really well, and there's a lot of potential using this kind of way that I did it to like get much better results.
Yeah, awesome. I'm sure the roadmap for 2025 is still very up in the air, but if we are going to see more agents work from weights and biases, I think the world will really welcome it.
Yeah, we'd love to. We'd love to keep going down this path.
Awesome. Any parting thoughts, Shawn? Anything we forgot? Yeah.
Calls to action.
Calls to action. Let's see. Parting thoughts. I don't know where all this is going. I think that we will have autonomous AI programmers working really well for us, within the next year or two. I think.
Have you guys tried Devin or Devin-like?
Yeah. We try to use everything internally.
Yeah.
I've used Devin. I think it's really cool. I think the UI is incredible, like all the work that they've done around that. I think that may be where most of the, like, if there's any mode here, it's going to be around like the interfaces into humans and their businesses. And Devin like has a major lead on making that work really well. It's like, there's a post floating around right now that says, oh, this didn't like get us the results that we want. Well, just wait like another 6 months until they plop the next great models in there, and you'll get good results and have a great UI on top of it. So, I think spending time focusing on UI tools, the business aspects of things is like the way to kind of succeed and win here.
Yeah, awesome. All right. Well, thank you so much. That was a really quick run through. Thank you for coming on, even though you're on paternity leave. But also, I'm sure your mind is still buzzing with all these ideas on what to do and how to compete. I mean, it's a very competitive arena, and congrats for coming out on top.
Yeah, thanks so much. Yeah, the next question is, does R1 do as well? So we'll find out.
Run it. I'm sure you have
Let
all
us know.
the setup you need. Yeah.
Maybe NVIDIA can bounce back if you fix it. All right. Thank you so much, Shawn.
Thank you.
Have a good one.